Okay, Math 140. We're starting section 3.3, and this is basically what we were doing in 3.2, where we were factoring polynomials. Let's just go ahead and start off by an example, and once you guys see this, you'll notice that 3.3 is literally what you've already done previously. So if our polynomial is 3x to the fourth minus 48x squared plus 8x plus 32, and we want to know if x plus 4, and what we're trying to do is determine if x plus 4 is a factor of this polynomial. So all we're going to do is, the key thing here is to remember that you always want to set it up like this, x minus k. So this x plus 4, we would rewrite it as this. So that way you have the minus k, and your k in this case is negative 4. So all we have to do is bring that negative 4, or our k value, out in front of the radical, and then we bring down all the coefficients in the polynomial. One note here again is we're going from 3x to the fourth down to 48x squared. So we don't have a cubed variable, so we want to make a 0 to hold that space. So your coefficients, or your underneath your radical, would look like this. Okay. So now we got our coefficients in there. We can go ahead and basically do exactly as we did last time. So this first number is going to drop down. These two numbers are going to multiply. Okay. These two numbers are going to multiply together. It's going to be negative 12. They're going to combine negative 12 and 0, and that will drop down here. Again, we're going to take negative 4 and multiply it by negative 12, so that'll be a positive 48. We'll combine negative 48 and 48, so that's 0. Multiply these two together, that goes here, so that's 0. 8 plus 0 is 8. Multiply negative 4 times 8. So negative 4 times 8 is 32. It's going to be negative. Combine those two together, you get 0. So because it's 0 right here, your remainder is 0, we know that this is a factor. That x plus 4 is a factor of our polynomial, which is f of x. So this is yes. Okay, let's do another example like this. So as you guys saw, this is pretty easy, and it's just like we had done in the previous section. So the first, basically 3.3 should be really easy for all of you. Let me write this out real quick. Let's see, plus 12x squared plus 5x minus 20. And again, we want to know if x plus 4 is a factor of this f of x, but we have to rewrite it like such. So we're going to have x minus negative 4, and negative 4 is our k, so that negative 4 comes out in front of the radical, and now we drop down our coefficients. X to the fifth, you don't see it, but you have a 1 there. The fourth is a 6, the third is an 11, the second is a 12, the first is a 5, and the 0 is a negative 20. And when I say 0, because you actually have an x or a variable to the 0 power, but anything raised to the 0 power is 1, so this here is technically, you don't have to write it. Okay, same exact thing as before. This is going to drop down. We got 1 down here. Multiply these two together, that comes here. Combine those two. Multiply these two together, so we got negative 8. Combine these two together, we have 3. Multiply these two together. Combine these, add them together, you got 0. It's going to be 0. So 5 plus 0 is 5. And we got negative 20 goes here. Combine those, you're going to have negative 40. So now this here is your remainder, and it is not equal to 0. So therefore, no, x plus 4, right here, x plus 4 is not a factor of f of x. So, like I said, it's pretty easy. So, kind of going pretty quick on it. Okay, now the next part that might be a little confusing on 3.3 is basically factoring a polynomial given the zero. When you're given an additional factor of that polynomial that's already known to be zero. So let's just look at an example real quick. 6x cubed minus 37x squared plus 32x plus 15. And in this example, they're going to give us what we want to do is factor this into linear factors if we know 5 is a 0 of f. So if we're given 5. So if 5 is a 0. So we know that 5 is a 0, so that's going to come out front and be our k. We drop down our coefficients. Let's see, so negative 37, 32, and 15. Okay, so this guy's going to drop down. There's going to be 30. Combine these two together, you got negative 7. Combine these, multiply these two. Combine these two, you got negative 3. Combine these two, negative 15, so that's 0. Okay, so now we've got 6, negative 7, and negative 3. We knew this here was going to be 0 because they already told us right here if 5 is a 0. 0 factor, that is. So what we have to do now is rewrite this quotient down here, 6, negative 7, and negative 3, but we have to incorporate the variables again. So what you do is you look at your original polynomial, and we see the highest degree is 6x to the third, so it's cubed. So then your quotient has to be 1 degree less. So we have 6x squared minus 7x minus 3, okay? Now, by looking at this, let's see here, we should be able to break this down into 2 more factors. So by doing that, or the next step would be, as we normally would, breaking it down into 2 more parentheses. Because we already know we have, let's see, x to the 5, so we have x minus 5. We already know this from right here. So now, this quotient here is going to get broken down further to get 2 linear equations. And the linear factors are going to be like this, where your variable x is raised to the first power. So you've got, let's see, 2x and 3x. So 2x times 3x will give you 6x squared. And then we need to come up with the negative 3 at the end. So we have to have a 3 and a 1, because only 3 and 1 multiply together to get negative 3. Let's see. So the next thing we have to do is decide if which parentheses get a plus or a minus. So you can go ahead and play with it when you come to this point, put a plus here, put a minus there, and you can FOIL these 2 out and figure it out if you're correct or not. That's basically just the guessing game. But I'm going to go ahead and just give it to you on this one. The first one will be negative, second one will be positive. So go ahead and if you FOIL all 3 of these out, you will come back to your original polynomial, and that's the whole game here. So again, as you saw, it's the same thing over and over, except this last step here where you just have to factor your quotient.